let's review a little bit of what we did yesterday. We're going to start with 66. Remember, we set up two radicals. We put all our perfect squares in one, all our leftovers in the other. So, like, for a perfect square with variables and exponents, it needs to be an even exponent. So a to the third is not perfect, but two of them are. And then the third one goes leftovers. B to the fifth has to be even. So we can put b to the fourth, and then our fifth b goes over here. C to the third, put 2, 1 leftover. When we square root the exponent stuff, you just divide the exponent by 2. So we will have a to the first, b to the second, c to the first, and then we have our root a, b, c. All right, now let's try 65. 20 is 4 times 5. 4 is perfect. A to the second, hey, it's even, so that's all perfect. B to the third, ooh, put 2 there. And the third one comes over here. Square root of 4 is 2. Square root of b squared is a to the first. B squared becomes b. And we have your root 5b. All right, now today we're going to be multiplying, and it's actually not that bad. We kind of did it yesterday. So I'll show you a couple kind of tricks that might help you. If you have the square root of 8 times the square root of 12, now they're both radicals, you can just multiply them together and keep it under a radical. So 8 times 12 is 96. And then you're trying to think of a perfect square that goes into 96. So you might be like, I know 4 does, but you might want to check. Like if you divide 46 or 96 by 4 in your calculator, you're going to get 24. And I know that 4 goes into that as well. So I'm going to try 96 divided by 16, because that's 4 times 4. And we get 6. So it's 16 times 6. And then the square root of 16 is 4. So you're left with 4 times 6. Now, I want to show you guys my favorite trick. If I have the square root of 4 times the square root of 4, that would give me the square root of 16, and the square root of 16 is 4. So if you ever have the square root of something times the square root of that exact same thing, you could essentially just drop the square root. Like the square root of 51 times the square root of 51 is just going to end up being regular 51. Or even the square root of smiley face times the square root of smiley face equals regular smiley face. So the reason I show you that is because on something like A, think of what goes into 8 and 12. And that would be like, I'm so excited I'm throwing markers. So 8 is 2 times 4, and then 12 is 4 times 3. And then if you know my little trickery, you could say, oh, well, the square root of 4 times the square root of 4 is regular 4. And then we're left with the square root of 2 times the square root of 3. You can multiply those together and just keep it in a root. 2 times 3 is 6. Ends up with the same answer, but you're working with a little bit smaller numbers. So that's why I like that trick. So let's try B. Let's try B with no trickery. So when you can multiply numbers outside the radical with other numbers outside the radical. 3 times 4 is 12. You can multiply things inside the radical with other things inside the radical. 2 times 10 is 20. B times B is B to the second power. And then we'll do what we do. Break it down with the perfect squares, huh? All right, so we got the 12 out there. 20, I know it's 4 times 5. B squared, that's perfect. 12 times square root of 4b squared would be 2b, or not 2b. I mean, that is the question after all. And then we multiply that with 12. 2 times 12 is 24. So 24b root 5. Yes!